Hi guys, Mrs. Russell here, just trying to help you with some of the thermochemical equations. I'm going to concentrate on the worksheets from it's number 7 and number 9 because they're the same types of problems. Those were the thermochemical equations. Big word, but nothing to be afraid of. Thermochemical equation just means it's a regular balanced equation. And then at the end of the equation, you'll see a delta H with a number, and the unit is kilojoule. Okay, this delta H means heat, and it has a name called enthalpy. So if you ever go on and take chemistry at a higher level, you'll talk about enthalpies of reaction and things like that. For us, we're going to use our value to help us to do some conversions. Basically, that's all you're doing are conversions with those equations. Okay, so delta H can be either a positive or delta H can be a negative kilojoule. Positive, negative. Heat absorbed, heat released. When it's positive, because the heat's absorbed, we call it endothermic. Okay? And when it's negative, heat is released, so we call it exothermic. And question A on every single one of the problems I gave you asked you to determine whether the reaction was an endothermic or exothermic reaction. So really all you have to do is look at the sign. If it's positive, it's endothermic. If it's negative, it's exothermic. So that's your answer for part A. Now, the way that the problems were set up, every B question was solved the same way, and every C question was solved the same way. So in the letter B questions, what you were given were grams of a substance. So you would go from grams to moles. All right, and I set it up so that you would do first part, convert from grams to moles. Second part, we'd go from moles to kilojoules. So for part B, when you're going from grams to moles, you're really multiplying by molar mass. But because gram is up here, when you draw your line, you have to put gram on the bottom. And the gram number is the GMM of the substance that we're working with. This mole here, because it's GMM, is going to be 1 mole. So part A has us converting from grams to moles. Then we get our answer. And our answer unit is mole. Okay, so then the second part of our conversion is to take that mole that we just found, and now we want to convert it to kilojoules. We want to know about the heat. Now the kilojoule, that's this thing up here. Okay, but the difference here is when we do our conversion, okay, if I have mole here, what has to go down here, because it's a conversion, would be mole, right? This kilojoule number would be whatever the number is they give you in the problem, okay? The mole number here is not 1, it's whatever the coefficient is for that substance in the balanced equation, because that coefficient relates directly to whatever the number is here, okay? So sometimes this number can be 1 if the coefficient is 1, but sometimes it might be 2 or 12 or 8 or whatever the coefficient is, all right? So then when you get your answer will be either a positive kilojoule, which means it's an overall endothermic, or it could be a negative kilojoule. And it would only be negative if this number here that you put in is negative. Okay? If this number is not negative, then this will be a positive value. All right, that's for part B. For part C, we're going backwards. We're going to start with kilojoule. The question's going to ask you how many grams of a substance are needed to produce an enthalpy change. Enthalpy is this thing up here. It's that H thing. To produce an enthalpy change. And then they'll give you a value for kilojoules, okay? So for that one, we're going to take the given means it's from the problem, the given kilojoules. We're going to do our first conversion, right? If I have kilojoule here, I have to put kilojoule here. Now, whether it's positive or negative here, don't write the negative down here because our final answer is going to be in grams, and we don't want a negative gram. So at this point, just drop the sign, okay? And then up here will be mole. That's the relationship. The relationship is moles and kilograms. The kilogram is whatever the delta H value is. That'll go down the bottom. And then again, the mole, this number here, will be whatever the coefficient is in the balanced equation. This will not be 1 unless the coefficient is 1. What that does is that gives us moles. See how both of our conversions will end up giving us mole. But now, once we have mole, then the second part is to take that mole that we just found, and now we're going to convert to grams, right? If I have mole here, I have to put mole down here, and gram will go on top. For this part, because this is GMM, right, then mole is 1 because that's the relationship between moles and GMM, okay? So this is the part where most of you were making your mistake, was when it was the moles with the kilojoules. You were just putting 1 there, all right? I tried to mark the number 7 papers, and I made comments on some of your on your work. I don't know if you looked at it. I did make some comments, but and that was really the biggest mistake. Okay, so let's look at this first example. This was example number 2 in the number 7 problems, right? Yep, number 7. Okay, so we have 4CO2, 6H2O, 2C2H6, and 7O2, and delta H was equal to a positive 2858, and the unit here is kilojoule. I forgot to write that in. That's a kilojoule. Okay, so part A. Is the reaction endothermic or exothermic? So where do we go? We go right to delta H, and we look at this value. When it's positive, it's endothermic. Okay, so answer to A is endothermic. Okay, that's A. Now, for B, B wants to know how much heat is released when 125 grams of CO2 is used. And we want to know how much heat is released. Okay, what we're looking for when we're looking for heat, what's the only heat unit we know is the kilojoule. Okay, so we have to convert from grams to kilojoules. And I broke it down for you so it would be like 2-step conversions. You can put them together as one if you want, but I, tried to make it as easy as I could. It's hard to teach this on a piece of paper when you're not there to ask questions. I understand it's very frustrating, and this is hard stuff. So, all right, so start with your given number, 125 grams. Now this is CO2. I'm only going to write it here. Times, draw my line. If I have gram here, I have to put gram on the bottom. If I have gram on the bottom, I put mole on the top. And because I'm converting from grams to moles, because I have mole and gram here, then this mole is 1, right? And then G will be the GMM of CO2. So now I have to add up the masses of carbon and the 2 oxygens. Carbon is 12, oxygen is 16. There's 2 of them, so that's 32. 32 and 12, that gives me 44. Now I can stop it here and calculate. Okay, so when I calculate, I have 125 times 1 divide 44. That gives me 2.84 moles. Okay, so that's the first part. Of course, I'm not finished because the problem wants me to find kilojoules, and I'm only at moles. So now I'm going to recopy my number down here, 2.84 mole times, and I'm going to draw my line. If I have mole here, then I have to put mole down here. And if I have mole down here and they want me to find kilojoules, then I have to put kilojoule up here. This is the conversion factor, moles and kilojoules. All right, so when I look at this balanced chemical equation, all right, every single thing in here has a coefficient. So this 4 relates directly to this 2858. This 6 relates directly to this 2858. The 2 relates to the 2858, and the 7 relates to the 2858. So what that means is when I put 2858 up here, then I have to put the coefficient that belongs to the substance I'm working with in this problem, which is CO2. So I go back into the equation, find CO2, and I want to know how many moles of CO2 do I have? Well, because the coefficient is 4, that means I have 4 moles. My mole unit will cancel. Now I'm ready to calculate. And 2.84 times 2858 divided by 4, that gives me, we'll say 2030 kilojoules. I rounded it. It comes out to be 29.8, so I just rounded it. Okay, and that's the answer to part B. It took us 2 steps to get there, but we got there. Okay, and that's what happens. For those of you that kind of can see the process, see how I repeated myself here and here? You don't have to stop at mole if you understand that this is the next conversion factor, and this could really just go right here, and then I would do 125 times 1 divide 44 times 2858 divide 4, and I'd still get 2030. Okay, so that's how you can do it that way as well. And every part B problem is set up that way. Now for part C, let's see, let's write this here. In part C, the problem wants to know how many grams of oxygen are produced for an enthalpy change of 1555 kilojoules. So 1555 kilojoules is what they give me, and they're asking for grams of oxygen. Now, another little mistake that some people made, they saw the word oxygen written out. Okay, so they used 16 for the mass of oxygen, but if you go up here, oxygen is actually O2. That's a diatomic molecule. That's one of those Hunkelbriefs, if you learned that. Okay, so because it's O2, there's 2 oxygens. So oxygen is actually 32, not 16. That was another mistake I saw on a bunch of papers. All right, but anyway, all we're doing here now is going in the opposite direction. Okay, so in this problem up here, we went from grams to moles, and then we went from moles to kilojoules. In this problem, we're going to go kilojoules to mole, and then we're going to go mole to gram. So we're just going in the opposite direction. So let's start with the first part. So 1555 kilojoule times, draw your line. If I have kilojoule here, I have to put kilojoule down here, and then mole goes on top. All right? So kilojoule, I go up all the way up to the beginning. Not here. This is just the answer when I start with 125 grams of CO2. So I go all the way up to the delta H value. All right? It's positive, and I want it to be positive anyway, so I'm just going to recopy 2858. So 2858 goes here, and mole on the top. Remember, this 2858 is related to 4CO2. It's related to 6H2O, and it's related to 2 of the C2H6, and it's related to the 7O2s. So whatever I'm working with in this problem, which in this problem is O2, then I have to use the coefficient from the balanced equation. So O2 is here. I have 7, so the mole will be 7. Okay? Kilojoule cancels. Now I can calculate 1555 times 7, divide 2858, and that gives me 3.81 mole. Okay, am I done? Where's the beginning? No, I'm not done, because what are they asking me to find? Grams. So I have to do the second part. So now I'm going to recopy my mole, all right? So 3.81 mole times, draw your line. If I have mole here, I have to put mole on the bottom. Remember, these are just conversions. You're just using unit conversions. Okay, I'm looking for grams, so now I'm going to put gram on the top. I should recognize that this is a molar mass conversion, a GMM conversion. So now I can put 1 there, and then the gram will be whatever the GMM of O2 is. Not of 7O2, just of O2, because I'm just converting from moles to grams. So oxygen is 16. Since it's O2, there's going to be 2 of them, so that would be 32. My moles cancel. I'm at gram. Okay, now I can calculate. So 3.81 times 32, divide 1, and that gives me 122 grams. So what this means is 122 grams of oxygen is produced when we use 1555 kilojoules of heat. All right, so, basically all you're doing is converting. So in B, we went from grams to moles, then moles to kilojoule. In C, we went from kilojoule to mole, and then mole to gram. We did the opposite. Okay, I want to show you one more. And this time it's going to be an exothermic reaction. Okay, this is actually on worksheet number 9, question number 1. So here's worksheet number 9, where I said your assignment for this week, that was last week, was to complete this worksheet by last Friday, and I only got 7 worksheets out of 18 students. Some of you guys really need to start reaching out to me. I get nothing, and you need to start doing your work, okay? If you're having some problems, you need to let me know, because I don't know. I'm not a mind reader. All right, so anyway, so here's the equation. Oh, actually, that's the wrong one. Which one am I doing? Oh, I'm sorry. I'm doing number 2, not number 1. All right, so I'm going to do this one. Okay? All right. So this is actually number 2. All right, so for A wants to know, is it an endothermic or exothermic reaction? So what do? We go right to the delta H. It's negative. Because it's negative now, we say it's exothermic. Okay, that's the answer to A. Now for B. In B, we want to know the amount of heat released when 102 grams of H2O is reacted. So 102 grams, and we want to know the heat. So what are we doing? We're going from grams, and we want to end up in heat, which is kilojoules. Okay? So we rewrite 102 gram H2O, I'm only going to write it there once, times, and I draw my line. If I have gram here, I have to put gram on the bottom. I put gram on the bottom, I can put mole on the top. This is a GMM conversion, so mole is 1 there, right? And I want to know the grams of H2O. GMM of H2O, okay? So H is 1, there's 2 of them, so that's 2. Oxygen is 16, so that's 18. My grams cancel, I'm at mole, and now I can calculate through, and when I calculate through, I get 5.66 mole. All right, that's the answer to the first part, okay? But I'm not done because I'm not at kilojoules yet. So I can recopy this, 5.66 mole times, draw your line. If I have mole on the bottom, now I can put kilojoule on the top. Okay, kilojoule. Here's my kilojoule right here. So this is the number I want. Because this is negative, I'm going to put the negative there. If that confuses you, just put the number in. Don't worry about the sign. All right, it's not that important. Okay, the kilojoules is 412. Now remember the relationship between the delta H and the coefficients. Remember, it's equal to all the coefficients. Okay, so what were you working with? We're working with H2O. So go up to H2O. The coefficient for H2O is 2. So down here, I need to put the number 2. because there's 2 of them. My moles cancel. I calculate through, and I get negative 1167 kilojoules. That's my answer. What if I leave this negative sign out? Then you won't have a negative here. It'll be 1167 kilojoules, and it really doesn't matter to me. Okay, just as long as you get the number right and you show your work, it doesn't really matter. Okay, so that is my final answer. Then in part C wants to know how many grams of CaOH2 must be produced for there to be an enthalpy change of 672 kilojoules. 672 kilojoules. Okay, and I want to know grams of CaOH2. Okay, and like I said, these problems are going to be exactly the same. In part B, you're going to do the exact same thing for every one. You're going to go from grams to moles, then moles to kilojoules. In part C, now we're starting at kilojoule, and we want to go to grams. So we're going to go kilojoule to mole, and then mole to gram, the 2 parts. Okay, so we start with 672 kilojoule times, draw your line. If I have kilojoule here, I have to put kilojoule on the bottom and mole on the top. Okay, kilojoule. Kilojoule is this number all the way up here. That's my delta H value. Always go back to the original delta H. So this number down here is 412. Now here's where it can get a little confusing. That's why I'm saying if you don't want to put the sign here, don't worry about it. Because here you don't want it to be negative. Because when you get your final answer, it would give you a negative gram, and you don't want negative grams, you just want grams. Okay, so we're going to drop the negative here. Like I said, if that confuses you, just take it out for all the calculations. I really don't care, you know, as long as you're doing the calculations right. All right, so what are we working with here? We're working with CaOH2, right? So remember, this kilojoule is related to however many moles of this calcium hydroxide, the CaOH2 we have. So go back up into the equation and find the CaOH2, which is here. All right, there is no coefficient in the front. So what number do we use? We use the number 1. See, here it is 1 because that's what the coefficient is. All right. All right, calculate through. Kilojoules will cancel. That'll give me moles. And let's see, that'll give me 1.63. But am I done? Mole, gram, of course not. So then we continue. So then I'm going to rewrite 1.63 mole times, draw your line. If I have mole here, I'm going to put mole down here. And then kilojoule here. Oops, no. Gram here. Sorry, we're going to grams, not kilojoules. So if I have mole here, I'm going to put mole down here and gram here. Now, this relationship, the mole will be 1 because it's GMM. Then I need grams of CaOH2, so I have to add that up. Calcium is 40. Oxygen is 16, but there's 2 of them. So 16 times 2, that's 32. So 40 plus 32, and then 2 H's. So when I add all that up, I get 74. My moles cancel. I'm at grams, what the problem wants, so I'm there. So now I can calculate 1.63 times 74, and that gives me 121 grams. And that's my answer. Okay? So if you haven't done worksheets 7 or 9, this is what you're doing. All right, so watch the video. I hope it helps. Get these worksheets to me if you haven't done them. And for those of you that keep doing your work, I really appreciate it. And just, guys, hang in there. You know, we'll get through this. Okay? All right. I am going to probably start doing lessons like this and uploading these videos as if I'm teaching you in front of the class. I'll just write everything on this piece of paper. Hopefully that'll help you a little bit better. Okay? All right, have a great weekend, and we'll talk soon. Bye.